Hi YouTube, this is Mike, also known as the Wizard of Odds, and in this video I'm going to be showing you how to calculate the odds for the game Caveman Keno in Excel. So if you're not familiar with the rules, let's start with a demonstration. Much like in regular Keno, you start by picking some numbers, in this case 2 to 10 of them, and I'm going to pick 8, and you can see the pay table over here on the left, and if we stopped right here, this game would only return somewhere between 40 and 50%. But Caveman Keno adds a special multiplier feature, which is going to be easier to explain by actually playing than to put it verbally. Okay, so do you see these 3 eggs on the screen at numbers 23, 50, and 59 in this case? What the game does is it picks 3 numbers from among the numbers you did not pick and puts eggs on them. And then there is the normal ball draw of 20 numbers by the game. And if you catch 2 of the 3 eggs, you get a multiplier of 4x. And if you catch all 3, then you get a multiplier of 8x. And don't take my word for it. Let me show you in the rule screen right here. It says if 2 eggs are hit, all wins pay 4x. If 3 eggs are hit, all wins pay 8x. So there you go. Let's play again until we win something with a multiplier. So nothing there. And while we're waiting, I'd like to say that I'm playing this at videopoker.com, where you can play a host of video poker and video Keno games for fun, meaning without gambling. And nothing there. Nothing there. So in this game, I hit 3 out of 8, which pays 1, in other words, even money, but I didn't hit any eggs, so no multiplier there, or really a multiplier of 1x, which is the same as no multiplier. So here we hit 2 out of the 3 eggs, which normally pays a multiplier of 4x, but we only hit 2 of my picks, which isn't enough to pay anything. So my win here is 0 times 4, which still equals 0. So the game, I guess, does not pump up the multiplier unless you actually win something. So here I hit 4 of my picks for a win of 2, but again, I did not hit at least 2 eggs, so no multiplier. So there I hit 4 of my 8 numbers, again for a win of 2, but 1 egg is no better than 0 eggs. It's just a multiplier of 1, so no improvement. There, we finally have a win where the multiplier rule takes effect. This took 7 minutes, by the way. I imagine I'm going to leave a lot of that play on the cutting room floor. So of my 8 numbers that I picked, I got wins on I caught numbers 37, 44, and 46. So catching 3 normally pays 1, and of the 3 eggs, the game caught the 2 eggs on numbers 26 and 72. So that kicked in the 4x multiplier, so the whole pay table automatically got multiplied by 4. Therefore, my win of 1 automatically became a win of 4. So I hope you understood that, and let me show you a couple other examples from when I was playing earlier. We are now in Excel and ready to start analyzing this game. I took the liberty of copying the videopoker.com pay table over to this spreadsheet to save some time. This is by no means the only pay table. As I have said many times elsewhere, casino managers can choose pay tables for Video Keno and Video Poker to suit their preference for how stingy or generous they want to be with their players. Over at videopoker.com, they nicely choose generous pay tables. But enough about that. Let's start by calculating the probability of catching 0 to 3 eggs. So with 0 eggs, so there are 60 numbers that are not drawn by the game. So if the player gets 0 eggs, it's one way to determine the number of combinations is to ask, how many ways can you choose 3 eggs from the 60 numbers that the game did not pick? And that can be expressed as the Excel function combin 60, 3. The first parameter is the number of the size of the set you're looking at, and the second parameter is the number that you are choosing from that set. And I plan at the end of the video to go over combinatorial mathematics really quickly. For now, I'm assuming you already understand what this function does. So that is saying that there are 34,220 ways to choose 3 eggs out of the 60 numbers the game did not select. How about 1 egg? Well, there are 20 numbers that the game did pick. So there are 20 possibilities for that 1 egg. And then there are combin 60, 2 ways to choose 2 eggs amongst the 60 numbers the game did not pick. So coincidentally, it's a very similar number. For 2 eggs, there are combin 20, 2 ways you can choose 2 numbers out of 20, and 60 ways you can choose the 1 egg that did not get picked. And the number of ways for 3 eggs is a number of ways to choose 3 numbers out of 20. So there are our combinations. So let's add that up to make sure we did it right. 82,160. And how many ways can you choose 3 numbers out of 80? The same number. So that gives me faith I did it right. So to get the probability of picking, or should I say, of the game choosing or finding any number of the eggs, you choose the combinations, divide it by the total combinations. So this is telling us there's about a 41.7% chance of finding 0, 43.1 of finding 1, 13.9 of finding 2, and 1.4 of finding 3. Now, we cannot simply multiply these probabilities and the number and the multipliers you get for them by the conventional math in Keno, because the number of catches that you get is negatively correlated to the number of eggs that get picked. Why is that? Well, for example, if all 3 eggs hatch, there are only 17 numbers that the game chooses left for the player's actual picks. So the number of eggs that hatch in the game, again, is negatively correlated to the number of catches that you get. So we're going to need to work out the math individually for each number of eggs that get caught. First, let's work out the probabilities of any given number of catches for the situation where the player catches 0 eggs. So the player can get anywhere from 0 to 10 catches. And we need to work this out for picking. Two to 10 numbers. So let's start out with something in the middle of this table. How about catching 3 out of 7 numbers? So the game has a ball draw of 20 numbers, and we can use the full 20 because we already are assuming that none of them were used on an egg. So we're going to do 20, 3 for the number of ways the player can catch 3 eggs. And now the player now we need to also choose 4 numbers that the player did not catch. So there are 57 numbers left that the game did not pick. And we are subtracting, if we were doing normal Keno, we would be putting in 60 here, but we already are assuming that none of the 3 eggs got caught. So there are 57 numbers left that the game did not pick and are not eggs. This is a very important step in this whole video, so feel free to pause the video and think about this a little bit. So for the number of misses, I'm going to do this 7 for the number of picks minus 3 for the number of catches. So in that situation, we get this number. Let's put a comma in there. About 450 million combinations. And we copy and paste this through the whole table. But if we do that, if the number of catches is greater than the number of picks, we'll get an error message. So let's head off that problem. So let's say that if the number of catches is less than or equal to the number of picks, then we do that formula that we just did. Otherwise, put in a 0. And notice how the number of catches is in column A. So let's put a $sign in front of all of these A's. So when we copy and paste that left and right, that A will not change. And the number of catches is in row 28. So let's put a $, in front of all those 28s. And let's copy and paste this formula through the whole table. And let's make some of these columns a little bigger. There we go. There are our combinations. And just out of a stylistic preference, let's add a total row to this table. And there we go. The combinations are key to Keno. So next, let's do the probabilities of any given number of picks and catches. So notice how I just copied and pasted that table, but let's change the heading to probability. And let's blank out all these combinations. And to get the probability, as I stated before, you take the number of combinations for any given situation and divide by the total. So in this case, the probability of catching 0 out of 10 is this number of combinations for 0 out of 10 divided by the total number of combinations for picking 10. And let's copy and paste that formula. And let's change these numbers to decimals so we can see what's going on better. Let's do 6 of them. 1, 2, 3, 4, 5, 6. So there are our probabilities. In our earlier case of catching 3 out of 7, That shows there is about a 18.7% chance. And now let's calculate the return. So let's save time and just copy and paste this whole table just to get the row and column headings right. And let's blank out the body. So to get the return, first let's take the probability, and then, and again, this is for 2 picks and 0 catches. Then let's go up to the pay table and get the win for that situation. And finally, since this is for catching 0 eggs, let's also multiply by the probability of catching 0 of the 3 eggs. And so this is 0 because that situation wins 0. And before we copy and paste this formula down, this C17 here was the probability of catching 0 eggs. Let's put dollars in front of both the C and the 17 because that is a fixed probability. And you can see that the number of catches is in column... No, I think that's the only thing that we need to fix. The rest of it we can copy and paste. Now let's basically repeat this all for 1 egg. So I'm going to copy and paste everything that I just did for 0 eggs and just adjust it for 1 egg. So here's our math for 1 egg. So let's go back to catching 3 out of 7. So again, this is really, really important and central to all this math, is getting this formula right. So now in this case, there are 19 numbers chosen by the game that the player might get his catches from. Why is it 19 and not 20? It's because one of those numbers was used for catching an egg. And now we're going to change this 57 to a 58 because there are now 58 numbers that the player... how shall I put this? There are 58 numbers that the game did not choose and are not eggs. And that's all you need to do to change that formula for catching 1 egg. And that adjusted all of the combinations. So let's slide over here to the probabilities. These should all be propagated off of the new formulas. Now, even though the total number of combinations, for example, you see right here in cells J40 and J58 are the same, just to have good style, let's divide by the number of combinations in that table. In other words, changing the 40 to a 58. Doesn't actually change the number, but sometimes style is important. And what did we do wrong there? Yeah, I know. So for the probability of catching 0 out of 2, we need to go back to our combinations for 2 catches. So B47 divided by B58. And let's go back here and copy and paste this formula. There we go. And for the return, whoops, I went too far. Let's just blank this out. So the combination to the return is going to be the probability, in this case catching 0 out of 2, times the win for that, which we can get in the pay table, which is also 0. And then let's multiply by the probability of catching 1 egg in cell C18 over here. And I'm going to put dollars in here because I don't want that C18 to change when I copy and paste this. So let's go back to our return table for catching 1 egg. And I feel it's safe to copy and paste this formula down. So there we go. For example, our return of catching 3 out of 7 eggs is about 7.4%. And you can see the total returns down here. And now let's do the same thing for 2 eggs. So here in our combinations, now in this case, 2 of the 20 numbers chosen by the game were used by catching eggs. So there's 18 left for the player's own catches. And there are now 59 numbers left for numbers that the game did not pick and are not covered by eggs. So let's change that 58 to a 59. And our number of picks is now in column 64. So let's change this 28 to a 64. It'll work without doing this, but again, just to make it a little more clear if you're ever looking at these formulas. So now let's copy and paste that formula down. The probabilities should automatically be adjusted properly. And for the return, let's blank this out. And again, the contribution to the return is going to be the probability for any given number of picks and catches times what it pays. In this case, we're doing 0 out of 2 times, in this, now the probability of catching 2 eggs, which is about 13.9%. And now, remember, if the player catches 2 eggs, he gets a 4x multiplier. So let's multiply by 4. And let me go back to our return table. And when we copy and paste this down, we don't want the C19 to change, which is that probability of catching 2 out of 3 eggs. So let's copy and paste that down. And voila, there are our returns for catching 2 out of 3 eggs. And now let's do the same thing for 3 eggs. Eggs 3, for our combinations, there are now only 17 numbers left for the player's own catches because 3 of the 20 got used by catching the eggs. And there are the full 60 numbers left that the game did not pick and are not covered by eggs. So let's copy and paste that new combinations formula through the whole thing. And the probabilities are automatically adjusted. And let's again blank out this return table. And for a return, again, we take the probability times what it pays times the probability of catching all 3 eggs. And now we're going to multiply by that multiplier of 8 for catching 3 eggs. And let's go down to the right location. and I think it's safe to copy and paste. No, it's not. We need to put dollar signs in the C20, the probability of catching 3 eggs. So let's copy and paste that. And there are our contributions to the return for catching 3 eggs. Now that we have calculated the contribution to the return for all these individual pieces for catching 0 to 3 eggs, we're ready to add them all up to get at the overall return of the whole game. So let's create another table here for that. And for catching 0 out of 2, for example, we're going to add the sum of doing that from the table for catching 0 eggs plus that of catching 1 egg plus the return for catching 2 eggs plus the return for catching 3 eggs. And let's copy and paste that down. And there we go. We can see that the total return for picking 2 is 95.05%, 95.25% for catching 3, and in all cases it's pretty close to 95%. However, so these are the returns for the videopoker.com pay table. I said at the beginning of the video that they are nicely generous over there. In a real casino, it's not so much, that's not so much the case. The slot managers tend to be more stingy. So let's put in a more realistic pay table, shall we? How about this one? And I'm copying and pasting from another source you can't see. But trust me, this is a more realistic pay table you might find in an actual casino. You might see the numbers all just went down, and let's see how that affected the total return over here. So now our total returns are closer to 88%, which is much more realistic. So under this pay table, for every dollar you bet, the player is going to get back about 88 cents, and the casino keeps 12 cents. And again, just based on 24 years of research, that is, I would say, an overall industry average of what Keno returns, maybe a little bit less. I think in most casinos you would find probably 88% or 90%. So that's it. That is how to calculate the return in Caveman Keno. If you understood this, feel free to leave now after giving me a thumbs up and hopefully subscribing to my channel. But at the end of the video, I'm going to go through a real crash course in combinatorial mathematics if you need that. So stay tuned for that, or I will see you in another video. So next I want to go over a little more slowly the functions that I was using to find the combinations. And as an example, I'm going to use the lottery game 649, where there are 49 numbers, numbered from 1 to 49, and both the player and the lottery pick 6 of them. So how many different ways can you choose 6 numbers out of 49? Well, let's work it out first the slow way. For the first number drawn by the game, there are 49 possibilities. Then once one number is drawn, it can't be drawn again. So there are 48 numbers left for the second ball, 47 for the third, 46 for the fourth, 45 for the fifth, and 44 left for the sixth. So this is telling us that the number of ways you can draw or choose, no, let me use the word pick. Pick 6 numbers out of 49 is this number here, 10,068,347,520. However, this considers order. In a lottery game, it does not matter the order that the numbers are picked most of the time. So we need to divide this by something to take the orders out of it. So we have 6 numbers here. How many orders can these 6 numbers have been drawn? Well, let's consider that there are 6 places you could put these numbers on the screen. So the first number drawn by the game, let's say that just by chance the numbers drawn were 1, 2, 3, 4, 5, and 6. So that number 1 could have been drawn 1st, 2nd, 3rd, 4th, 5th, or 6th. So there are 6 different orders or positions possible for that first number drawn. For the second, there are 5 positions left. For the third, there are 4. For the fourth, there are 3. For the fifth, there are 2. And for the last one, there is just 1 position left. So there are 720 ways you can order 6 numbers. However, you don't need to actually do this, write out this formula. This number here, 720, is known as 6 factorial. That is the number of ways you can order 6 items. And in Excel, you can get at that function with the fact function, in this case fact 6, and there is our same 720. So to get the number of combinations, or the number of ways to pick 6 numbers out of 49 without regard to order, you take this original number of permutations that we calculated before and divide it by 720. And that gets us down to a number close to 1 in 14 million. So the odds of winning a 649 lottery game would be 1 in 13,983,816. However, you don't need to do all that to find that out. Excel makes it nice and easy. The number of, as I explained before, the combin function, to use that, the first parameter is the number of items in the set that you're picking from, in this case 49, and the second parameter is how many of those numbers you're picking, in this case 6. So that gives us that same number of combinations right there. And not that permutations matter in the lottery or Keno. If you do want to know the number of ways you can pick X items out of Y, you use the permute function. So in the case of picking 6 items out of 49 where order does matter, you use this permute function. And the other parameters are the same. And this gives you that same number of permutations that we calculated up in cell 81. So there is your crash course in combinatorial mathematics. And that brings me to the end of this video. Thanks again for watching YouTube, and hope to see you in another video. Bye.